or 47%. So when you check the map itself, actually, you find the green percentage is mainly dominated in the outer side of London as a green belt area, which is very weird. So there are some councils and policy makers are trying to figure out what shall we do next, as like GLA is trying to increase the green area percentage. TfL Transport for London is working on London environmental strategy called Healthy Streets to motivate people to walk more, to decrease the pressure on transportation, and Walkable London by Zaha Hadid. So this is a plan actually I'm working on, London Future Plan 2050 by Sadiq Khan. So he wants London to be bigger, better, to be 50% of London to be green. Is it applicable? Which places should we start with? How to apply it in our city? When I look also in the same research, what actually people are looking at, top priorities for Londoners actually looking for more parks and green space. By 33% of them are really need these things, and attractive new buildings and environment by 58, almost 60% as well. So I thought about why we don't mix both of them and see different alternatives. So instead of just greening as trees, maybe making green facades as living wall or living facade, what other alternatives we can have. That's why to go on and see which places are the top priority to apply green systems, I had to look where urban heat in fact has the peak temperatures. So through the green map, I got to know central London. Then further on, I got to need that we need infrastructure or planning to have 10% more green infrastructure. So I decided where shall I go, where shall I lead to, how I'm going to go through this. So I decided to see where is urban heat effect, air pollution, then which type of urban green system I'm going to apply, trees, green walls, changing albedo, pavement, changing the percentage of these green systems as well, and see which one is more applicable and which one is better in each street orientation, canyon orientation. So first I had to specify unhealthy canyons and streets which has having pollution or heat as well. Then later on I had to specify which canyons urban heat island effect is happening or occurring within it more, which is more frequent heat stress. So I had to, through literature review, specify the unhealthy canyons which has high probability of urban heat island effect, so I can start with it. So applying it, I found one of the most polluted and unhealthy canyons during Oxford Street, one of the highest polluted streets and more condensed and having a high economical value for the whole UK. Then I narrowed the canyon. Then I started to think about it, okay, if I'm going to look at the canyon from the east-west direction, which is the main location orientation for it, I have to study as well north-south with the same aspects and ratio. Then I'm going to simulate it through EnviMat simulation. But while simulating it, I have to also indicate that there are like 6 grids in each canyon orientation, north-south, called S1, street 1, street 2, east-west. And I'm going to place receptors, which is equivalent to human bodies at level 1.5 meter, 1, 2, 3, 4, 5, 6 receptors to indicate which one will have the highest heat stress, and same for S2 until 12 receptors in total. Later on, I decided to see what alternatives I have. I have trees, this is applicable. I have green walls, could be applicable as well. I have the percentage, and I thought about green roofs, but green roofs will not have direct influence on pedestrian thermal comfort. It would have over the urban heat island effect, but my main focus on pedestrians, on people health. So I decided to eliminate green roofs and replace it by pavement albedo to change the pavement albedo. So I had different alternatives. The basic case actually for the building, which we have seen here. Then I have changed different types, changed albedo, pavement albedo to be reflective up to 0.8, changing green trees 25%, and the most optimistic by Mayor of London to be 50%. Same for living facade, 25 and 50%. Then I decided which receptor, as we have mentioned, the people who are in each street direction will be receiving the high thermal stress. So I found that two receptors has the highest heat stress, which is number 6 in S1 and number 12 in S2. And that's due to having more solar radiation, which we're gonna notice. Then I focused my study more to compare between the results of each alternative. That the more green we apply or we use, we will have higher relative humidity, while with wind speed it will be lower by more trees. When we got deeper to measure predicted mean fault and physiological predicted discomfort levels, they were mainly defined or used for indoors environments. That's why they don't use solar radiation, but we needed to get to know more how people will feel as a measure, as a sensible measure in the beginning. Afterwards, we apply physiological equivalent temperature, which takes more considerations into account, and I can judge more air temperature, main radiant temperature, and surface temperature. To reach this point, it was very surprising that the north-south street, which is S1, had a similar physiological equivalent temperature. Like this is a basic case, while the other alternatives, either albedo or living facade or trees, didn't have much difference. And that was a very weird surprise. We expected that more green will have better performance and then better thermal comfort. But surprisingly, in north-south direction, and in this urban canyons, which is more dominant within central London, it doesn't have high solar radiation because it's north-south, and actually buildings having shading effect, and it's in the wind direction, so it's more thermal comfort is applicable. While in the east-west canyons, the more green, the better thermal performance is happening and occurring actually, while the changing pigment albedo has increased the heat stress and discomfort levels, and that's due to the reflectivity of the sun and the solar radiation, while the trees had a higher thermal comfort levels due to its shading effect. One more interesting part, which was found later on as one of the conclusions, that actually not increasing the percentage of greens would lead to more thermal comfort. You have to specify which canyons you will prioritize, and if you're going to apply for the 2050 plan, you have to specify which streets you will start with, which orientation would you apply, which type of green or plants will be looking at. Physiological equivalent temperature was more precise to show us to indicate thermal stress and thermal comfort levels more than just air temperature or surface temperature, because it managed all of them and reflected on each other, connects the whole gap together. High albedo pigment has high influence on surface temperature, but high mean radiant temperature as well. This is why we apply it to north-south street, which has lower solar radiation. And east-west canyons, trees are more advised for it. And actually, if you're going to decrease the percentage of trees, so I would advise you to apply it on the street from east-west, the upper part, which has more sun. Last thing, it's recommended to run more simulations for 2050 and 2080 with different alternatives based on this one, and link it to air pollution levels, because sometimes urban green systems could be as trees might trap pollution underneath it. So we have also to take pollution into consideration, which I'm looking for in the next paper. Thank you so much.
It's really interesting to see both the study in Hong Kong and London shows that increasing the greenery, not 100%, make sure like it can have better cooler environment. You have to have a detailed design simulation to give the more information. So, is there any questions?
Thank you for your presentation. I'm curious about how do you locate the street canyons with high UHI and high air pollution?
Pardon?
How do you recognize the street canyons with high UHI and high air pollution?
In London, we have a website which indicating it indicates hourly, monthly, yearly air pollution rates within each street canyon, including particulate matters, nitrogen oxides, COs, ozones. So all of these are monitored each hour.
And what's your target periods?
So actually what I'm doing now, I'm comparing between 2018, so this simulation carried out for the average of summer season. So it's summer, it's the average of the whole summer I have carried out in the simulation for this whole summer season, and I'll be doing the same for 2015 and 18 and see how much difference would be, because temperature will be different. It's not only high, but it's expected to be windy. So I have to go back to the meteorological office and contact them to ask them about this phenomenon, why it's expected to have more wind in the future, why it will not be more drought. Although it would be like summer will be more drier, winters will be more windy. But I have to get more physical phenomena explanation before running future simulations.
أنت كذاب أبو صلاح.
Your conclusions, you talk about more generic approaches, if I understood your conclusions correctly, about east-west and north-south streets. But London's morphology is quite varied. So the area you looked at near Oxford Street's very long, and there's a certain configuration of buildings and microclimates there, which would, I think, vary quite significantly neighborhood to neighborhood. So I'm wondering if you need to be a little bit more careful about drawing conclusions from a case study and scaling that up. I'm sure that your conclusions are correct, or I'd like to think they are for that particular site, but I think you also need to look at other sort of morphologies in London, which are quite different.
Yeah, I totally agree with you. That was actually the beginning, the first discussion of my research. Where shall I pick, which point needs to be prioritized? Where shall I start first? So I picked the most generic one, and then I summarized it to see where are unhealthy canyons are occurring, and so on. So it was not just city center because more people. No, I picked unhealthy canyons with this dimension and this morphology. And actually, so if you apply it on this unhealthy canyon, it could be in other unhealthy canyons within the same rhythm, not exactly, but it would be within the same range. You could apply it. While discussing with TFL, one of the problems when we have been discussing why include in living facade, although city center is more historical buildings, you cannot just green wall the building, it's not logical. So while we're discussing with them, they had a problem even with trees. They told me, actually people are using pavement, you're putting trees where we are going to place trees, so people have to walk less or in a limited areas. Although I gave them as an alternative, it could be street furniture. You afford a place for garbage, you afford a place for car lights, traffic lights. Why don't you use tree as a street furniture as well? It could have different alternatives actually, but depending on what would you like to do. Instead of applying trees on both sides as I planned, in the future I'll be looking at one side which has higher thermal stress, so you afford more space for people to walk. Instead of having traffic lights, signs, or garbage, you can put it on trees, so tree would be more like as a street furniture and you can put more things on it. One of the professors also asked me before, which type of trees are you using? What type of tree? Is it mature, young, small? Actually, I did research on what's the percentage of green area now in central London. It's 0.001% of London main streets. When you take all Oxford Street, you will get almost 0%. What type of trees? I got to street plans, a map for all trees, all their types, their size, and I measured them. I checked which type, which one is applicable more for London. Is it like deciduous tree or like evergreen tree? It's deciduous, while in winter we need more sun, so it has to be without green during winter. What size? It has to be mature, because otherwise when I count the percentage of coverage area, it has to be bigger. Otherwise, I have to place different trees to do the same coverage percentage. So all of these details I have been carrying out more in depth in the research itself.
Okay, thank you.
One objection I've heard to tree planting on urban streets is the conflict with services, below-grade services, water, sewer, electrical cables, gas, etc. Have you come up against that in this work?
Actually, there's also researchers have been, not researchers, people who supply trees, green walls, like architecture firm, as a tree, they're making actually for street trees would have a deeper roots, right? And need more water. So actually they designed a water efficient tree with controlled root, which can fit within small size or area. The tree will not grow bigger, but you can get the size which you need also from them. So it's more controlled. Because it was one of the challenges, how deep the roots will go. There are buildings already in the area. So this is one of the things.
دي وسعت منك دي يا أبو صلاح.
Okay, thank you.
Thank you so much.
Thank you. We had talks from started with Hong Kong and Chengdu, London. Now